So let's start with your oxidizing properties of permanganate. So as I said, I've given you a list of oxidizing properties and different reactions which is prescribed for your syllabus. So I've picked up one important reaction. Let us do all the 5 in acidic medium and neutral medium. So first, doing such reaction, basically how is this given in the exam? This particular question is given in this way: MnO4 minus plus C2O4 minus 2. They'll give you this, and they'll ask you to complete it. You have to complete it. For that, we are going to follow a method called half-cell reaction method, which you have studied in your grade level. Now, once this question is given to you in the paper, now what did I write here? Here I've written the complete reaction which I'm supposed to get, because first initially you're learning. I think you've forgotten your this in grade 11th only. So first I've written what should be obtained. This is the final answer. We'll do here and compare it with you. Now, whenever you have to do, let us do it stepwise. Step 1. First, pick up that basic reaction which is given to you in the question paper. MnO4 minus C2O4 minus 2. Right. How should I remember which product? Basically, I said oxalates or oxalic acid to carbon dioxide. I said that. Iodines or iodide to iodine. Sulfides to sulfur. So, that basic thing you have to remember and go, and then it will be easy. So, now this one, Mn plus 2, and oxalate is going to form carbon dioxide. This thing at least you can remember, I think. Yes. So first important thing is calculating oxidation numbers. Calculating oxidation numbers. Right. Now start with the first one. Now this is the metal atom, X plus 4 into valency is minus 2 minus 1. X minus 8 plus 7. So manganese oxidation state is plus 7. Done. So let me erase this. Now let us come back to oxalate. Now calculate oxidation number here. This is 2x, isn't it? This is x, and this already we know, 2x minus this is plus, isn't it? Initially, okay. So 4 to the then it becomes minus 8 minus 2. 2x is equal to plus 3. I have got oxidation state of carbon as plus 3. So let us write as plus 3. Done. Let me come back here. This is already Mn plus 2. Now for carbon dioxide, this is minus 2. Yes. So when this is minus 2, this is minus 4, isn't it? This should be plus 4. Because minus and plus should get cancelled and becomes finally 0. Now let us erase this also. Now first step is done. Now in step 2, you are going to see which is the oxidation, or which is undergoing oxidation, which is undergoing reduction. It's the same procedure for all. Now when I have to see in this particular thing, okay, if you want to write the reaction again, not a problem. MnO4 minus C2O4 minus 2, you can write here also. I am again writing plus 2 plus CO2 plus 4 plus 2. Now I've got this is plus 7. Now from here, you will see what is happening to this Mn, and from here see what is happening to this carbon dioxide. Now here manganese from plus 7, it has gone to plus 2. So what happened? It started gaining electrons, isn't it? 7, earlier it was plus 7, it has lost 7 electrons. Now it has gained and come back to plus 2. Don't get confused. Higher oxidation to lower oxidation state means they have gained the electrons and underwent the reduction process. Gaining electrons is reduction. So from plus 2 to plus 7, how much? 7, it's 5, isn't it? So how much has it gained? It has gained 5 electrons. When it has gained 5 electrons, what process does it undergo? What process has it undergone? It has gone under reduction process. Gain of electrons is reduction. Now here from plus 3, it has gone to plus 4. What happened? Now from higher to lower is reduction. From lower to higher is oxidation. How many electrons has it lost? It has lost 1 electron. When it has lost 1 electron, what process do I call it as? Oxidation process. Simple. Now your step 2 is done. Now come back to step 3. Now write half cell reactions. Half cell reactions means anodic reaction, cathodic reaction. Now here one has undergone reduction, one has gone oxidation, so divide. Take that oxidation reaction here. This oxidation reaction always happens at anode. Take that reduction reaction here. This reduction reaction occurs at cathode. Done. Now write the oxidation reaction half cell. Divide into 2 equal halves. So your oxidation reaction is this, isn't it? Write that C2O4. Copy with the charges, not a problem. It is giving me carbon dioxide -2 +4. This is your +3. Now come back and write the reduction reaction. What is the reduction reaction? MnO4 minus is forming, or it's Mn +2, and the oxidation state is +7. Yes, done. I have written half cell reactions. Now important, once you write the half cell reactions, just try to balance the atoms here. Now here carbon is 2. So let us write half cell reaction and balance. Balance atoms. Now here carbon is 2. Here it is only 1. So try to make it 2. Done. Let's come back and see. Manganese is 1. Manganese is 1. Oxygen, I'll balance it later stages. Done. This is also done. After that, let us come back to step 4. Here you said oxidation, here you said reduction. You have to see how many electrons got lost and how many electrons have gained. Here in reduction process, it has what should you say, reduction is gain of electrons, isn't it? Which has gained electrons? MnO4 has gained 5 electrons. That's why the reduction process you will write as gaining. The oxidation you will write as loss. Okay, it has gained 5 electrons. And here what happened? Oxalate, how much it has lost? It has lost 1 electron. Correct? Hope you understood this. This has lost 1 electron outer side. This has gained 1 electron inner side. Done. Both are. Now in step 4, you are going to take these two half cell reactions and try to balance with oxygen. You have to balance oxygen. Let us write. Write this reaction first. I'm going to, okay, let me draw a line. Take this oxalate, right? -2. Now 2 CO2 plus 1 electron. Oxidation cell reaction I have written. Then copy this reduction reaction here. MnO4 plus 5 electrons gives me Mn plus 2. Now I have to balance your oxygen. How will you balance oxygen? Just observe acidic medium I said, isn't it? When I say acidic medium, you have to be very careful. You have to balance oxygens on whichever side is less. Again, whichever side oxygens are less, that side you will add water. Yes, hope you understood this. Just see in the final reaction, where did I get water? I got water on the right hand side. So let us come back and see. Now on this particular thing, how many do we have? You have oxygens, 4 plus 4, 8 oxygens. On this side, how many do we have? You have only, now just see, your 2 twos are 4 only, isn't it? You have only this one 4 oxygens. So how many are excess on this side? You have 8 here, you have 4 here. So you're going to multiply with 4 water molecules on this side. 4 water molecules. Simple. 4 plus 4, 8 oxygens. 2 twos are 4 oxygens. So to compensate that, I have multiplied with 4. Done. Now again, to compensate this hydrogen, you are going to add on this left hand side. Right hand side water, left hand side protons. So how many hydrogens do we have? Now oxygen is balanced. 4, 4, done. Now hydrogens of 4 twos are 8. Try to add 8H plus on this side. Done. Yes, we are almost coming close to the reaction. Now, one important thing, this part is done. In the next step, in step 5, now you have to be careful. What are we doing? We are going to cancel, okay, let us write, in step 5, we are going to cancel electrons. How are we going to cancel electrons? First important thing, you have to see, here when I have written carbon dioxide 1 electron, for 2 carbon dioxide, so for 1 carbon, 1 electron. For 2 carbons, how many electrons? It should be 2 electrons, isn't it? Simple. Yes, so here also 1 carbon was 1 electron, 2 carbons was 2 electrons. It should be 2 electrons. Done. Now you're going to cancel electrons. What should you do? Here, to cancel the electrons on LHS and RHS, simple. Here what do you have? You have 5 electrons here. Here you have 2 electrons. Now cross multiply. This 2 electron try to multiply with this. This 5 electron try to multiply with this. Then what happens? We have cross multiply with this number. Again, 5 electrons to cancel these 5 electrons, I have multiplied here. To cancel these 2 electrons, I have multiplied here. Just simple, isn't it? Now 5 into 2 electrons will get cancelled on the RHS. 2 into 5 electrons will get cancelled on your LHS. Done. Once this is done, let us write the overall reaction. You have to be very careful here. First important thing, this 5 is common to all. This 2 is common to all. Just to cancel the electrons, I wrote it, isn't it? Now start. When you're writing this reactant, 5 oxalates. So 5 C2O4 minus 2 plus. All right on the reactant side, below oxalate, what do you have? MnO4. Just below, how many are there? 2 plus 2 MnO4 minus plus. Electrons got cancelled. There's nothing here. After electrons, you have 8. 8H plus, when you multiply with this becomes 8 to the 16H plus. Done. Let's come back to the product side. When I have to write the product side, now again start. 5 is common to whole. 5 into 2 is 10 carbon dioxide plus electrons got cancelled. Below carbon dioxide, what do you have? You have Mn plus 2. How many do you have? 2 Mn plus 2. Done. Plus water molecule, 4 into 2, 8 more water molecules. Let us come back and compare with the main reaction. This is your main reaction. 5 oxalates, correct. 2 MnO4, correct. 16H plus, correct. 10 carbon dioxides, also done. 2 Mn plus 2 done. 8 water molecule done. This is how you are going to balance the half cell reaction method. Let us meet again with the next oxidizing property of KMnO4.